to review the test tubes for everyone so that you have a better understanding of the different additives found in the test tubes that we use in the laboratory. So I pulled up this laboratory quick collection reference guide that we passed out in lab, and I want to start by looking at these groups of tests. So first off, this here we have the marble top, or you may hear us refer to it as the tiger top, and the gold top. These have clot activators in them, and they also have a gel in them that separates the serum when we spin it. And in lab, you should collect these when we start drawing blood, and we're going to go ahead and spin them so that you can see what it looks like when the serum is separated by this gel. So it has a gel in the bottom of the tube. They're considered red top tubes, and the reason there's a marble or a gold top tube is because of just the type of top it is. We do have this, we call it a HemoGuard top, which prevents splashing when we open it. So we do have a red top tubes that look like this, and then they talk about the red top tube. Now the red top tube is also a serum tube, and they are used, it just doesn't have the gel barrier in it. So these tubes here that I'm circling are all the tubes that create serum because they clot. They have no additive or a clot activator in them. So either a clot activator or no additive. And if you look over here, there's a clotting time that's required. And what we're trying to do with these is we want to make sure they clot before we spin them, so they use up all the clotting factors, or the fibrinogen that's found in blood, which is a clotting factor. So when the clotting factor is used up, it's called serum. And these are what we call serum tubes. So that's these tubes right here. Now going down to this tubes, these are the green top tubes. There's a light green and a dark green. They all have heparin tubes in them. These say lithium heparin, some say sodium heparin, but they're heparin tubes. Refer to them as heparin tubes. What makes them different is the additive of the heparin. So no clotting is required because the heparin is an anticoagulant, and it'll prevent the tubes from clotting. So if you look up here at these serum tubes, these are all the tests that we run on serum tubes. So a lot of chemistry profiles and panels. And if you look at the green top tube, we also have chemistry profiles and panels. So they're very similar. The difference between the green top tube and the red top tube is that the green top tubes, we don't have to wait for them to clot. Where the red top tube, we have to wait 30 to 60 minutes for them to clot. And think about that when you are in a hospital and you have stat chemistry panels ordered. If a doctor needs test results stat, meaning right away, we don't want to wait 30 or 60 minutes for it to clot before we can start testing it. And these we don't have to wait, so we can start testing it right away. So the green top tubes are really used for stat chemistries, and the red top tube, or the marble top tube, is commonly used for outpatient chemistry testing. And that's the difference between the two. This one, the gray top tube, has sodium fluoride potassium oxalate in it. That is an anti-metabolite or an anti-glycolytic, so it stops the metabolism of the cells using anything in there, any of the additives that we're testing in there. It says lactic acid, and we do draw lactic acids in gray top tubes, but I want you to add a couple. We also draw alcohol levels on gray top tubes, and if we're doing a glucose tolerance testing, we'll draw glucoses on gray top tubes. Only for really glucose tolerance tests. That's the only time we really use a gray top tube, because we want to stop any metabolism that's happening inside there. Remember, the cells in here are still alive, so they can still utilize analytes like lactic acid or alcohol or glucose. So by the sodium fluoride potassium oxalate additive, it will prevent the cells from continually using those analytes. And that's a gray top tube. Again, no clotting time because it has an additive in it. which prevents it from clotting. So the green top tube has an additive in it, which makes plasma. The gray top tube will make plasma. Now we have the purple top tube. This is EDTA, K2 EDTA. That's our additive here. It is a plasma tube. It will make plasma if we spin it. However, typically we do CBCs on this tube right here. And we usually draw all of these here that you see, all these tests. We use whole blood. We test whole blood on it. So we don't spin these tubes. There's no clotting time because it has K2 EDTA in it. So again, it will interfere with the calcium in the tube and prevent clotting. So it has an anticoagulant mixed with the blood. And this is used for hematology. Now, a pink top tube and a purple top tube have the exact same thing in it. It's a K2 EDTA. The reason we do a pink top tube and a purple top tube is it differentiates departments. So the purple top tube we send to hematology, and if a patient needs some blood banking work, such as a type in cross or a type in screen, or they need a cross match, a unit of blood, we send it to the blood bank. So this is a tube that we use for blood bank. However, these tubes actually have the exact same additive. The color difference is just for departmental. This tube is the light blue top tube, and we've talked about this one. This one's a very important tube, and it has a lot of requirements on it. It's used for clotting factors, so we measure coagulation studies on this. A PT-INR, a PTT, fibrinogen. So this one has sodium citrate in it, and it must be full. We cannot short draw this. It has to be a 9-to-1 ratio, meaning 9 parts blood to 1 part sodium citrate. This one doesn't have any clotting time because it has the anticoagulant additive sodium citrate in it. And it says right here it has anticoagulant in it. And we're going to send this to the coagulation department, which is actually located in the hematology department. These two tubes are very rare. They also can have EDTA, and some of them make serum. We typically draw these alone. We don't draw them with any of the other tubes that you see above. They're used for lead levels and zinc levels and heavy metal, mercury, like any heavy metal levels. Typically drawn on children and usually drawn separate because we don't really know that that's the issue till later. So these are rare, and you may be tested on them, meaning you need to know that they're for heavy metals, but they typically don't fall in the order of draw. So the last thing I want you to look at is this here, which shows you the order of draw, because this chart's not in the order of draw. So we always draw a sterile tube first, like if there's a blood culture order, we always want to draw that first because we don't want anything to contaminate it. But it's rare for us to always draw blood cultures with the set, so typically they're drawn alone. But if we do have an order of draw, we always really want to draw our light blue top tube, which is our sodium citrate tube, then our serum tubes, which include any one of these up here. So this is kind of grouped together. So on this chart down here, we just put a red tube because it's the red, the tiger, the gold, because they all create serum because they don't have any additives in them. They just have a clot activator or no additive. Then we have our green top tube we draw next, which is our heparin. Then we'll draw our EDTA tubes, which are purple and pink tubes. And we finish with our gray top tube, which is an oxalate tube. So this will show you your order of draw as well. So I hope that helps you kind of understand this chart a little bit better. Really focus on a couple highlighted tests that are up here. Make sure you pay attention to the clotting time and what additive is in each one of these tubes. Those are some things that you need to know for your future exam.